All right, here we go. Here's a crash course in simplifying radicals. Basically, your goal here is to factor this 200 with its factors, using the factors of 200, create a factor tree until you get prime numbers like 1, 3, 5, 7, 11. 9 is not a prime number because it can be divided by 3, or a perfect square. Now, a perfect square is a number that is made up by a square. So, for instance, if a side were 3 and 3, your area would be 9. Therefore, 9 is a perfect square because it's made up of 2 equal sides. So, when I look at 200, and of course, what you'll start to realize is that there's more than one way. There's more than one way to solve or simplify a radical here. But in this case, I'm able to get down to a perfect square, and I'm able to get down to a prime here. So perfect square, square root of 100, 10, square root of 2. Now, I want to look at it again and just say, okay, what if I did 25 and 8? 8 is not a perfect square or prime, so I'll continue, and then you'll see I'll end up with 2 perfect squares, and I'll end up with a prime here. And I have 5 times the 2 times the square root of 2, and I end up with 10 square root of 2. And you could use square root of 200, you could use 40 and 5, and 20 and 2, and 4 and 5. And I like this one because it allows me to show you that idea of the repeating radical. Kept fishing into it. So see that the prime number of 5 repeats itself. And the idea is square root of 5 times square root of 5 is square root of 25. Square root of 25 is 5. So anytime you get a prime number, a radical of a prime number repeat itself, it just becomes that number, and that's where that's where you get the 5 from. And then you have your perfect square of 4, which is 2, and then you have your prime number of radical 2, and you end up with a 10 radical 2 once again. And this can be done for any number. One I like to bring up too is that 150, and here's why. 150 is going to break down to 25 and 6. Now 6 isn't a prime number, so you break it down to 2 and 3. But recognize what happens. You end up with a perfect square of 25, which gives you 5. But these two prime numbers, 2 and 3, they don't help you simplify or come up with a perfect square or come up with a repeating radical. So you end up with square root of 2, square root, or radical 2, radical 3. So actually this final answer is going to be 5 radical 6. And so whenever you end up with 2 radicals, you're basically going back to, sometimes you're going to have to go back to what this is. And you'll see a 5 radical 6. That's kind of a special case there. The other part of this, looking at the variables and when they present variables to us, and I'm just going to go down the line, A9, B8, C7, D6, E5, F4. I'm going to skip HI. I'm going to skip to a J here. Okay, so here we're looking at all our letters and see if we could come up with a pattern. Basically, if I were to take square root of a to the 9th, it could be written as a, because this is a second root, a of 9 over 2. And 9 divided by 2 is 4 and 1/2. And if I were to do 9 divided by 2, basically with the long division house, it goes in 4 times, and you get a remainder of 1. So when we're simplifying these radicals with the variables, This number is going to go outside the radical, and your remainder is going to go inside. So let's look at that. I have 8 to the 4th, and we'll start inside the radical here, 8 to the 1st. Now, 8 divided by 2 is 4, so I just end up with b to the 4th, and because there's no remainder, there's no longer going to be, there will not be a b on the inside of this radical. 2 goes into 7, I'm working with this here, the c to the 7, 3 times, and we have a remainder of 1. Notice anything left in the radical is always just going to have a exponent of 1 because you're dividing by 2, so the greatest remainder you'll have is 1. I have d to the 3 because 6 divided by 2 is 3. E to the 2, E1. F2, G, we're running out of room here, but you get the idea of what we're doing with. Let's go to J though. Let's say I had H2, I'll just split it up here, J1. This would kind of look like H on the outside because 2 divided by 2 is 1, no remainder, and J on the inside. If you cannot divide the 2 into the exponent, like J1 here, then you're just going to leave it inside your radical. Let's say, just to finish, we end up with one of my favorites, 72 x8 y9, we'll call it Z3 W1. Again, many different ways you could work with 72. I'm going to try to use, best I can, numbers in which are going to give me perfect squares the quickest way. For here, I go straight to a radical, straight to a prime. I have 3 times 2 on the outside. The 3 comes from here, the 2 comes from here, and then so I end up with a 6. I'm looking at my variables, 6x to the 4th, no remainder. Y to the 4th, there'll be a remainder of 1. And I have this 2 still on the inside. That's where the 2 is going to go. 2y, z1, z1, and then the w is left on the inside. So my final answer would be 6x4, y4, z. You don't have to put the z1 there. 2y, ZW. That's a good example, which is showing a lot of different parts there. If you end up with like a prime number as a radical, let's say it'd be 41. Well, that's just your simplified answer. Throw that one in there too. So this is simplifying radicals, numbers, and variables.